Hello clickers, welcome back to Click Technology. In the previous video, we discussed about development of mini games using Python platform. So today, in this video, let's discuss something different. Well, today we will be going to discuss about operational amplifiers, also known as op-amps. Before discussing more about op-amps, let's discuss about its applications. Name itself says that it is used for amplification of signals. Not only for amplification of signals, it is also used for signal generator, signal filter, voltage regulator, and current regulator. So, what is an op-amp? In simple language, it is a device which is used to amplify signal and it has high amplification factor. So, a feedback circuit is added to control its amplification factor. What is the circuit symbol of an op-amp? Circuit symbol of op-amp is shown in the figure. It has two input terminals, which is inverting input and non-inverting input, and it runs on two voltage sources, plus VSS and minus VSS, and it also has an output. When a signal is passed through inverting input, then a signal which is out of phase when compared to input signal is generated. When a signal is passed through non-inverting input, a signal which is out of phase when compared to input signal is generated. So now let's discuss about the ideal characteristics of an op-amp. Number 1. Infinite input impedance. It means when a voltage source is connected to input terminal of an op-amp, it draws no current from voltage source. Hence it implies that input impedance of an ideal op-amp is infinite. Zero output impedance. The voltage at output terminal is independent of current drawn. Hence op-amp can drive infinite number of devices. Infinite voltage gain. When a signal is passed through an open loop, voltage gain is infinity. Infinite bandwidth. This implies that ideal op-amp can amplify signal from any frequency ranging from 0 to infinity. Next is perfect balance. It means when a same voltage is applied to both the input terminals, then the output generated will be 0. Infinite CMRR. CMRR means common mode regulation ratio. For an op-amp, output common mode noise voltage is 0. Infinite slew rate. Slew rate indicates rapidity at which output changes with the change in input, and for an ideal op-amp it is infinity. Temperature. Characteristics of an temperature doesn't change with the change in temperature. Up to now we have discussed about ideal characteristics of op-amp. Now let's see what are its practical characteristics. For an ideal op-amp, voltage gain is infinity. For a practical op-amp, voltage gain rise in the range of 10 power 4 to 10 power 6. For an ideal op-amp, input resistance is infinity, but for a practical op-amp, it is few mega ohms. For ideal op-amp, output resistance is 0, but for practical op-amp, it is few ohms. For ideal op-amp, common mode rejection ratio is infinity, but in practical, it is about 90 decibels. For ideal op-amp, bandwidth is infinity, but in practical condition, it lies in a range of 1 to 100 megahertz. For ideal op-amp, slew rate is infinity, but in practical condition, it is few volt per microsecond. And and the last thing, power supply rejection ratio is 0 for ideal op-amp, but for a practical op-amp, it is few microvolt per volt. Now let us discuss some characteristics of LM741 op-amp. This is a LM741 op-amp. It has 8 inputs, which is GIP packaged. It requires a minimum of 5 volt for its function, and its input resistance is 2 mega ohm. Output resistance is 75 ohms. Voltage gain is 2 lakhs. Maximum output is 20 milliampere, and slew rate is 0.5 volt per microsecond. Thank you guys. Let's continue in the other session.